Hi again, guys. Fred Kynes with All Kinds of Classics here on a kind of a unique video. The series up to now that you've been watching, and all the way through, I don't know what's released at this point, but I believe episode 10, um, is hitting this week, I think, or may have already hit. And in that episode, we're back there in June, July timeframe of 2022. Today is the 17th of September, 2023, and I'll call this a special episode to kind of show you, begin with the end in mind. Now, this is a unique episode in the sense that it has nothing to do with me constructing or fabricating. It has to do with the results of what happened with the plan for the engine. So, after episode 10, you'll see the migration. The body will be in epoxy, and the migration to focusing on the powertrain. And I went through a whole bunch of issues back then, ideas, concepts, but I landed on a frame, and you'll see all that. But I opted to go with a special engine and a special control for that engine. And this is the end result of that control. I'm not going to give away all of the videos, but that are coming. But I do want to share, and because I'm excited. I'm excited. And over the course of the last 2 or 3 days here, we've made some significant progress on the powertrain. And I think you'll like this video. There is a lot of talking into it because I basically, over the course of this video, explaining what I did to make this combination work. So it's the test and tune was spectacular. I have not at this point driven it because the car is not complete. But please take an opportunity to review this video, take a look through it, fast forward if it gets boring for you. But the reality is, in this, you will see how I put this combination together, and with the help of hotheads and Gail from Gail Co. Getting some of the periphery things settled out. We came up with, and many others, but we were able to get this scenario put together. Please take a look, comment, like, subscribe, share this with anybody you'd like, any company, anybody else that you'd like, because I am excited about it, and I want people to see what I've been able to accomplish here. So enjoy, please enjoy. Hey guys, we had a real good day yesterday, working on the Dodge, on the Hemi. And I wanted to kind of describe what it is I'm doing. I don't really know if I've posted enough information on kind of all of the details surrounding the installation of the motor using a 2000 Ram 1500 PCM power control module, and then building out all of this fuel injected throttle body, all of that kind of thing. So now that we got it all together, I had my brother over yesterday who does a lot of work on reprogramming, or has done a lot of work on reprogramming these computers, and he came for a visit. So he brought his hardware with him, and then we went into taking a look at this. We learned a couple of things. One thing, on the old do your homework. I didn't go back and take a look at interface, but his software was only capable of 2004 and newer. I believe it was 2000. Yeah, it's 2004 and newer PCMs. And after a little searching on the internet, I found that that winds up being one of the trials and tribulations of programming OBD2s prior to that era. In this case, Chrysler, the 98 to 2003 PCM is a little harder to crack. You could buy chips, and there's other elements that you can do, but the journey's not over with that. That is the longer range plan, is to get in and do some programming. But for those of you that are in that side of things, I was learning for the most part. But one of the key elements is to, it's really just air and fuel, right? And then all the other sensors. But it's really to get the engine to run. If you've got the compression, that's all the hardware in the build. It's getting the air and fuel mixture correct over the dynamic events that involve the sensors. So what we did do is we were able to monitor everything necessary, all the vitals, and validate that we were well within. In this case, 18% was the high, and the air fuel ratio in the learning process for the controller. And so we're still within the design spec of it learning and getting back to an optimum running engine, and but then getting in and turning off the evap. There's a number of them. I actually have them written down: leak detection, evap, the battery temp. Some of those things that were features on the 2000 Dodge Ram that are unnecessary features on a hot rod, and I don't want to go through the process of installing any of that type of equipment or sensors. So we're going to shut all those off, and the thought process is that nothing's impossible, right? We just need to find the way. So through different relationships that he has, we're going to identify with how we can move forward and get this some of those other things done. It's not a showstopper, but I want to use the check engine feature, and I don't want it going off for false alarms. So I think that's vitally important, so that I can plug in a scanner if I need to, if I have a problem with a O2 sensor, an injector, or whatever, a TPS, whatever, that I can identify it, find the trouble code, go in and resolve the issue. So at this point, though, we're so early in the game. We've got the engine in the stand, in the chassis. We've got the temporary watered up engine, and we got it temporarily wired. And I'm going to show that stuff to you right now, as far as where we're at this point, and without further ado. So here we go. We've got the this is from a 98 Dodge Dakota. I didn't want the great big primary box, engine control box, whatever, but the primary box under the hood that feeds into the with the master fuses feeding to the relays and the ignition and under dash fuse box. So what I did is I grabbed the 20 bank fuse box and the underhood relay box and main fuse box. And so at this point, I've got it wired in with wire nuts and through the harness, through the Magnum harness, using the wiring diagram. And in this case, in this Dodge Dakota, it came with 6 pockets for relays. 5 of them were wired. I had to wire the 6th hole. 2 of the relay banks, and you can see, because there's only 1 blade, not a second, in that hole and in that hole. The rest of these main breakers or fuses are used to run the interior and the various engine controls. These 2 in this case run the relays in the PCM. So what I did is, at this point, because the harness, I'm going to mount that on the inside along with the fuse box under the dash, and I'll enter into the firewall with this, whether I do a connector like the original one, like the original 1500. I won't use this style, but a bulkhead connector or not. The jury's out on that. I'll figure that out later. But also the PCM, which is on the other side, that was mounted up on the firewall on the engine side. In this case, that'll be on the interior on the passenger side. And so through another grommet, or some sort of firewall access. So that being said, this is all temporary wiring. I even used, wire nuts and labeled everything to be able to get this to a point of starting. I'm using a trailer plug to my dashboard, which is my ignition and start, and my starter feed is just a connection to the battery. Then I run the ground. Of course, I got all of my grounds connected, and I got a ground wire from the block to the chassis. I'm running a alligator clip ground from the PCM, just as another level of assurance of ground back. And then I got a battery positive cable that goes up into this box. So with the battery sitting on the floor, I do have the alternator wired, so because that runs through this harness, so I wanted to validate the entire system that involves the PCM and the wiring here. So that's why there's a rat's nest down there and the temporary wiring, as you see. Over the course of the day yesterday, we fired and we had some issues. Now you can see this is if you followed this at all, this is a 331 from 1953. It has the extended bell housing. My son and I designed the adapter plate to interface the automatic 4-speed automatic transmission, electronic control, to the crank. In much earlier videos, you saw how I fabricated the starter to interface with the 143 tooth Magnum ring gear, because that's attached to the, in this case, the overdrive or lockup torque converter. The one thing that those of you in the know recognize is that that PCM runs on a crank position sensor that is mounted, that is the flex plate. I'm going to walk over and just take a quick look at it. That is the flex plate for the Dodge. In this case, the donor was 5.2, or 5.9 or 3.7, but the Magnum engine. And the pickup coil looks at this and finds one of 8 windows to identify the position of the crankshaft and enable the spark firing through the PCM and the advanced control and all that. We know with the Dodge Magnum that the distributor does not provide any advance or retard features. Rather, it's the cam phaser, and it provides the opportunity for, based on the coil firing, based on the firing event from the PCM through the coil, to direct it toward the right plug. Now, you start monkeying around with trying to advance this, and you get your rotor in the distributor halfway between or slightly closer to one or the other. It's going to just arc fire to the wrong cylinder. So monkeying around with this for advance and retard is a fool's game. It does not provide, it provides more problems than it does solutions. It takes your cam sensor out of phase, which the cam sensor says, hey, when do I fire an injector based on the position of the crankshaft? Do I fire this injector or this injector? And so on and so forth in that firing order. So in order to get to identifying with the crank position, I moved the crank position sensor to the front. And there is the factory Dodge crank position sensor. It is connected to, get some light, a reluctor that you can see, whoa, right there. And you can see right there is a notch. There's a notch right there just before it. And it has 8 notches that are the width, the identical width, in this case 400 thousandths, so like 396 thousandths of the window on the flex plate. and they are positioned 45 degrees from each other around that reluctor wheel. Chrysler does a beautiful job in producing their lower pulleys. They're hub-centric to the crank. They have 6 bolt holes 60 degrees apart, and the surface behind the pulley on many versions of this is flat and concentric. So I made 3 different designs of that. Now I'm going back, of that reluctor wheel to replace this design. One was right here. One was right here where I provided slots. That was my first design, provide slots, get the diameter bigger than the harmonic balancer. And this is slightly, I believe the diameter of the harmonic balancer is the valley of each of the slots. That was option 1. Option 2 was to mount it on the hub of the lower pulley, and with the same outer diameter. And option 3 is the one that you saw in the engine, which was a smaller diameter, because at that time I searched and acquired this pulley that provided me about 1.5 inches of space between the harmonic balancer and the first pulley. So then I could get down farther down in there and use my factory OEM throttle position sensor, or crank position sensor. Now you can see I stacked washers, and there is limited adjustability, but enough in this case to get me to 30. I'm at 32 thousandths clearance from that reluctor wheel to that sensor. Now the journey of positioning that reluctor wheel properly was a challenge. And originally, because you're reverse engineering back to a factory, to the position of the flex plate slash reluctor from the Magnum to the actual position of the crank position sensor, and where it was relative to the degrees of angle relative to top dead center. I guess that's the best reference. And what I learned through blogging was that there really isn't a good, successful, singular story out there. It just was significant research. So in this case, I did wind up finding several people trying to do this same thing. Number one, no huge success stories. One guy with a 6-cylinder that appeared to have some success, but not enough information to provide me detail. So when you're thinking about this stuff, the real issue is that because it's the flex plate and it is the 6 bolts on the Magnum engine that are designed such that flex plate only goes on a specific way, there is no field related adjustment per se to identify where that first hole is relative to the crankshaft position without having a Magnum engine setting here and with the harmonic balancer on, the crankshaft on it, and walking around and doing it. Now, I didn't have that luxury, and looking back with the amount of time that I spent doing this, I certainly could have gone to the salvage yard, found a Magnum, without a transmission on it or an engine out, and gone down that path of identifying precisely where it was. I didn't do that. So initially what I did was I went to the Dodge specification for identifying the location of the cam position sensor. Okay, the distributors put into the specifications for identifying pin 1 on the distributor, the position of the distributor assembly, and clocking the distributor so that it's pointed to pin 1 before you put the cap on. That occurs at 17.5 degrees after top dead center. from what I could identify online. And what I did was I set that reluctor wheel event at that same position. So as I'm probing, I hit my 5-volt signal at the same time on here as I did on there for cylinder 1. The engine did fire, it ran, but I had problems with it. And then I had the trouble code, the what is it, 1495, I think? No, that's a leak. I can't remember what the code was, but the code was, you know, there's a sensor, there's a cam or crank position sensor condition. Went back and looked and was able to, and maybe I mentioned this earlier, but was able to identify that well, wait, let me back up. So we need to recognize that I timed the cam events in phase at the same time as the crank. And what I learned was that caused the timing advance, my crankshaft position was not allowing for appropriate fuel distribution or the injector events. The sequence was out, was not working properly. So basically, I got the engine to a point where it would idle, and when it went into open loop, I couldn't even give it throttle. You know, it was just a strange condition. It would run, but I'm throwing that code, and I couldn't give it throttle. So after significant research, I learned that and looking at oscilloscope tables, guys are providing those online, but I found one from a master mechanic for a stock Magnum engine. And that's what I wanted to do. You know, again, all this is, if I would have just grabbed an engine and done my homework on a physical engine, I would not be trying to reinvent what the engineers did with the crankshaft position sensor being the basis of all the rest of everything. You can't adjust it. When I looked at the oscilloscope information, I saw that the crank position sensor followed, that 5-volt signal followed the cam position sensor by 22.5 degrees. Okay, relatively speaking, looked at several different scopes and said, wow, there's my problem, or at least an opportunity to identify if that is indeed the problem. Now, for you old Dodge LA block folks, the V-belt lower pulley has 6 bolts in it. And of course, you can line it up however you want, as long as you line the holes up. You can clock it however you want, as long as you line the holes up, indicating that those holes are 60 degrees apart. The crank the reluctor wheel, has the notches 45 degrees apart, meaning that I have an opportunity to index, if you will, that crank position sensor to find that optimum location for the cam position, for the reluctor wheel relative to the cam position sensor. I know this sounds confusing, but basically what I did is I pulled up my DXF, my AutoCAD file for that cut that I sent off to have that cut, for my son to cut that for me. And I overlaid the bolt holes and indexed it on the screen, on the computer, 1 position, 2 positions. And on that second position, I was able to achieve 22.5 degrees. Out of phase events for the 5-volt signal, for the signal, for this position sensor relative to that. In the same direction. So that hits 22.5 degrees before that hit for cylinder number 1. So basically, I just unscrewed that pulley, took the belt off, unscrewed the pulley, clocked it to, bolted it back on, and I was confident in my mind that this is going to be the solution. I bolted it on, fired up the engine, and it ran beautifully. It just ran beautifully. In closed loop, I ran it for, it was almost a half an hour straight. I cycled the throttle and, did a whole bunch of different things. And so I knew it went into closed loop, and it still ran. I had throttle, I had everything else. So I know I'm ready. I'm ready to start to have my brother plug in and start to take a look at the reading the engine vitals, find the vitals, see if we can get this Magnum 5.2 liter Magnum controller to operate on a 5.3 Hemi. Before he came over, one other thing occurred that was really troubling me, and that the IAC was calling for air at idle, 100% duty at idle, wide open, and I had a rich condition. Not that my code reader identified it, that my nose read it, and visibly seeing black smoke coming out of the exhaust. I could crack the throttle open and it would clear up, and that would be great. Pulled the plugs. Plugs were rich. Really rich. Really rich at idle. Had a brief conversation with my brother and said, we got to get this IAC thing in control. And he said, well, it's all air. Something's wrong. Adjust your throttle cable. Adjust my throttle cable. What? Well, your blades are probably too far shut. And then I realized, oh, shit. So I opened this up to a 53 millimeter throttle body. I built new throttle blades, and I recalled at that time holding that sucker up to a light, popping that plug out, and closing the throttle blades completely to make sure that I had them properly centered, on the shaft, that I wouldn't have a skewed situation where I'd have gaps. And that was all part of the setup when I was building or modifying that throttle body. And oh shit. So I fired the engine up and took this is a torque screw behind here. I don't have the plug in here. And and kept going. And as I was opening the throttle, it would rev up and then come back down to idle. And that IAC would start to modulate. Oh, it's working great. Kept going. And pretty soon it wouldn't modulate. It started revving up. Well, it saw a voltage signal on the throttle position sensor at that moment. And there's a range, it's probably almost a full turn. It's certainly more than a half a turn of where that needs to be. So I would back it off of that event where it would not idle back down. I'd back it off to idle. I'd index it up a little bit more. Say it was 3/4 of a turn, I'd go a half of a turn, it would still idle. Then I'd crack the throttle and it wouldn't come back to idle. So then I'd back it about 1/8 of a turn, crack the throttle, 1/8 of a turn until it came fully back to idle. So now I've positioned my idle screw to run that to take that duty cycle of the IAC down, which was less than 10% then. Then it was modulating very well and not creating a signal from my O2 sensor, meaning that the controller was saying, hey, it's an idle condition, it's an idle condition, it's an idle condition. So that got that in tune. Then we plugged in, and the only things that occurred then after we were getting into this whole test and tune was reading all the vitals. Oil pressure is good, 20 psi, 25 psi at idle, hot. Um, um, Engine temp sensor in this location is only hitting 160. I'm running a 200 on, 185 off. I want this thing to operate around 190 to 200. That's cycling. That's a little slow to go into closed loop in an open condition like this. The fan cycling to go into open loop, I mean. So the jury's out on whether or not I will relocate that to next to the fan sensor in the thermostat housing or not. On the Dodges, that's where it's at. It's right next to it. On the Magnums, it's right next to the thermostat housing. But our collaboration indicated that let's just leave it here for now. If it lags going into closed loop, that's an option. It's an easy option. So we're going to leave that. I had a drip on the fuel roll. I don't know if I mentioned that. So I pulled off. These two seals were wet on the bottom side of the injector. I replaced the seals. Upon assembly, I must have scraped the O-rings when I was sticking them into the fuel rails, and I bought a set of those for that very reason, because I knew there was going to be some sort of an emergency. It's just the assembly's pretty tight tolerance. And my O2 sensor had an erratic reading. I bought a Chinese O2 sensor, and the pins, we would unplug it and plug it in, and it would validate on his PC in the program. And so I bent, during the time we were testing and tuning, I bent the pins in a little bit so that they would scrape the walls, but the pin diameter of the pin to the Chinese connector, the barrel, was a larger diameter than the pin, so it was touching erratically. So then I got a package of these weather packs, and this is a Delphi style weather pack, so I went to a 4-blade in this style, and then that's this, and fix that. Other than that, the RPM range, the operation, the throttle, no lags, no hesitations, nothing, runs beautiful. Obviously, haven't done the ride and drive yet. That'll be down the road some. But the flip side of the coin is we were talking about specifically with regard to the O2 sensors that is still in a rich condition. And what started at idle at 18%, 18.1 or 18.2%, and by as we were going through, we're down to 14%. So we were playing at the throttle to try to build the chart at all the different events. But of course, since I can't drive it, I can't really put it under any significant load. I can't really create drivability conditions now. We deemed this process a success. His software won't go into that PLC. The days where you'd send it in and have it a chip installed, or I probably could do that too, but we need a program chip, and I'm not going to get a Magnum program chip for it, and I'm not going to chip it. My brother's going to go back with some resources that he has working with people in that industry that may or may not have an alternative method, an older software or something like that, where we can get in here and we can start running it. So I'm going to continue to moving forward. It is a success. It runs off of that controller. I'm less than 25% out on my air fuel, which means it's learning its way back. By the time we were done, we were 13% out as it was going through its learning events. Obviously, those were all occurring at under 1,000 RPM because of where we're at with this. With basically idle, no load conditions. So I need to get this. The next phase will be to get the body on it, drive it, build that table, build that logic into the PLC, and where the battery is going to be connected, and I'm not going to start fresh every time, and then I'll more than likely send the power control module to him to read the tables and work any optimization from there. So this is exciting. It's very rewarding, and from what all of the research that I've done, there has been significant conversation on, hey, can I move that reluctor off of that because I want to put on a 5-speed. I want to do something like this. I want to do something different. Can I get one for the front with the 8 positions? I like using the OEM stuff because the OEM stuff is more reliable. I hate Chinese sensors. I don't hate Chinese products. I hate the sensors and stuff like that that are close tolerance because their quality processes don't have the same stringent requirements that OEMs do. So if I could, a used one from an engine would be better. But under the circumstances yesterday, I wasn't going to go do that. That's the only sensor. The engine temp sensor is the only one in this case. This is a Chinese sensor for the fan, but that's the only non-OEM sensor on this whole shooting match at this point because it's a sensor. It runs, works great. It's a beautiful thing. I think at this point, it's a stone cold engine, but let's just see at this point if I can get him to fire. So the first thing I need to do is liven it up with bat. Bat positive, negatives connected, starter. This old one-handed thing is on a there. So I got my starter wire, got my bat wire. Everything's good to go. Yeah, so we'll fire it. There we have it. That's a success. Thanks, folks.